And so to begin, I'd like to say good day to a mate who's showing up from Melbourne, Australia, a place that I enjoyed living at for a number of years. And kind of surprised someone from down under is attending tonight. So I hope not disappointed. So the title talks about ISO 29148 and MBSE practices. And I'm really going to narrowly focus on just basically half of one page of that 90-page standard. And I'm going to convey how I believe requirement patterns relate to property-based requirements and how terminology is important to the development of both controlled vocabularies and conceptual models. Now, the work of conceptual models is really inspired a great deal by this gentleman, Giancarlo Guzzardi. This is his thesis work that's represented there in the right-hand corner. And he's motivated a lot of thinking for me when it comes to MBSE and how to represent elements in a model. The difference between roles and classes, a very distinct difference. And I see a lot of models where roles really get incorporated just as a class and not as a role. And on the left-hand side is the text Model-Based Systems Engineering by Patrice Miquon. Now, Patrice is who inspired the property-based requirement approach that's in the current SysML standard. It's actually in a non-normative appendix in the end. And this presentation, the models we're going to look at are available on my personal web server, which is available here at this mbtutp.noip.me. And I'll leave this server up for a week, 10 days. And so in here, you can see that the models are available. There are the presentations here, if you're interested. And there's some documentation, like Guzzardi's, a paper of his, and a couple papers from Wymore, who I'll talk about, who I think is an important contributor to systems engineering practice. So, okay. Technical difficulty. Okay, I won't really spend a great deal of time on this slide. It kind of covers the last 20 years, the 50 years I've been doing integration and test. And I say I started my test career back in 1971 when I was 16 years old. And I started as a technician doing repair work on commercial electronic equipment. So I started out with models, schematic diagrams, and I've worked in this field of integration and test and systems engineering, for 50 years using diagrams, whether they be schematic diagrams or block diagrams or using UML and SysML and some other notation. So I have some experience, and towards the end of my career at Lockheed-Martin, I was the technical lead of integration and test model-based test engineering practices. And that was a group that individuals like Laura Hart, John Watson, Christopher Oster, you may recognize those three names because I know that Laura and John are still active in the SysML today. So I'm going to try and go through these slides rather quickly and get into the models. So this is the extract from 29148. And so it mentions that all terms specific to requirements engineering should be formally defined and applied consistently. So I believe that's making reference to a controlled vocabulary. And it's asserting that this is something you really need to do. It's really not optional. You really should do it to have an effective requirements repository. And I personally agree. The bottom bullet about conditions are measurable, qualitative or quantitative attributes that are stipulated for the requirement. So what you'll see when we get into the model is how I tie the conceptual model into the natural language of the requirement, so that even when a property is qualitative, that quality is sufficiently defined that we share the understanding of what that quality really means, which I would argue isn't really the case today in many cases. In the center, we have just one requirement pattern. Some people call this a boilerplate. And I'll show you in a few slides how this concept of essentially a pattern of the structure of a natural language requirement ties into property-based requirements. So if we were to look at what essentially is a conceptual model of a natural language requirement, that conceptual model might look something like this. Actually, when I was going over this diagram today, the only defect that I found that I would probably change is that action, which is really the function that's stated in the natural language. Multiplicity really should be 1. So we're saying that the condition clause is optional. And if there is one, there's only going to be one clause, but it could have many elements to it. There's only going to be one subject, so that's the satisfier of the requirement. There's going to be a single action. There may be an object that the action impacts, and there may be a constraint. And we're saying that there's value specifications for the event, the states, and the constraints. And this is what's important, because to have value specifications, we really should be looking at instance specifications where the slots of a class or a block actually have a value property assigned to them. And although I know that there are many people in the MBSE community using SysML, put default values in classes, the reality is, I think that's an inappropriate use of defaults. A prescriptive model really should be done, in my opinion, with instance specifications. Having problems clicking in the right place. So this topic of conceptual models, which relies heavily on the work of Giancarlo. On the left-hand side here, we have this triangle, which is referred to as the semiotic triangle, sometimes the Ullman triangle. And its intent is to convey this triad of how we understand things in a world, the reality. That we create symbols for them, but the symbols really require a conceptualization associated with them. So even if it's a word, right, that's merely a symbol. It's no different than a block or a constraint in the UML and SysML. It is a symbol that we attach a conceptualization to. In a language, in a natural language, that would be a definition. And it might even have examples of usage, right? So that you get a better understanding of what that symbol actually represents in the real world. So the dotted line that's labeled refers to between symbol and thing. That really is an indirect, right? The real relationship between a symbol and the thing in reality, things like dreams, a car, an ocean, a cloud, is all through this conceptualization that is represented by the symbol, and the conceptualization abstracts the thing. So I see a lot of models that use words and stereotypes and symbols for which no definition has been created. So to an outsider, someone who's not a member of that community of discourse, the model is ineffective as a communication tool. And that's what the illustration on the right is conveying, is how the language can be used, the modeling language can be used to create a specification model. And just like in 15288, you have essentially two tiers. You have this modeling language, which could be like in the UML or the OMG case, it could be the MOF, the Meta Object Facility. And from the MOF, you create the UML. From the UML would move up to the modeling language, and you might create a model of software. Or if we're talking SysML, the SysML is the modeling language, and then this is a system model. So you can have a hierarchy of these models. And I argue, and you'll see why when we get into the model, that the conceptual model can play a very important role in a quality MBSE artifact. A lot of words here, but I think what I've highlighted in yellow is the takeaway. You know, first of all, an instance of the conceptual model. So that's really the symbol. Conceptual model is the symbol. It's a thing, right? It's an artifact that's an output of a process. 15288 tells us that these types of things are artifacts of a process. And the conceptualization of a conceptual model is that it's a description of a given domain, and it's independent of design or technological choices. And that's what's really important. It's independent of design or technological choices. And it supports an understanding, problem solving, and communication of a given subject domain. And so that conceptual model can be used as a blueprint for subsequent phases of a product's development using models. And none of this is my original thought. I have to give credit to Giancarlo and his work in ontology and conceptual modeling. So cycling back to 2948 and this concept of the importance of terminology and controlling it and documenting it and using it uniformly, a controlled vocabulary is an essential element of that conceptual model. And as Tim Vielkens talks in his SysMod, it's probably kind of a zigzag relationship. You might work on the model a little bit and realize there's a new concept that you have to name or define and enter it into your model. So you'll go do that in your controlled vocabulary, and then you'll go back to your conceptual model. So it's really a back and forth. The two are kind of built in parallel. Once a controlled vocabulary and a conceptual model for a domain are created, you don't ever have to do that again. You shouldn't have to do that again. That would go under configuration management, and you would just reuse it. When that domain model, conceptual model, is relevant to a system you're developing, you go pull that out of your configuration management repository and access it, use it in your new model that you're working on. So the controlled vocabulary, it achieves an unambiguous representation of a subject's reality. And so when I say subject, right, the subject of a sentence is that noun object that the sentence is about. If a model has a subject, I would argue that it's the system that is the subject of that model. That's when I use subject, that's what I'm thinking. And so this controlled vocabulary also helps us understand the objects in the world of the subject, the relationships of those objects, and the rules. defines the scope or meaning of the symbols, right, the terms. And it creates this uniform conceptualization of the symbols within the community of discourse. Right? This is what's really important. So as a model creator and as a model user, if we don't share the same conceptualization of the symbols that are used, that model's not going to accomplish the level of communication that we want it to. And so the control vocabulary is codifying this symbol to thing that refers to relationship. And that's why I believe it's so important. So in the UML testing profile, version 2, an OMG specification for testing, there is a section 7, which is a conceptual model in natural language and figures. And so it states right in the introduction that it's informative, right? Which means it's not a normative aspect of the standard, but it's included to help the reader get a better understanding of the concepts behind the UML testing profile. It illustrates the semantics of the concepts. And it also is a pragmatic application of the OMG specification, the semantics of business rules and vocabularies, a standard to help you construct controlled vocabularies. So I'm going to play about 90-second promotional video of a product named Simient. And Simient is a tool based on artificial intelligence to help extract vocabulary elements from existing documentation. And I'm going to show it, and hopefully you'll hear the sound, because Michael says in 90 seconds what would take me 10 minutes to say. And it's a very interesting tool that is being developed.
Bridge organizational silos and align teams by providing them with a common language with Simient, your virtual quality assistant. Modern products are getting increasingly complex, requiring specialized tools for development, but this leads to a work environment that is fragmented into siloed activities and data across software, hardware, quality, systems, and risk teams. It does not stop here. Stakeholders outside product development are losing alignment with the core asset of the organization, the product. This unintended information gap and misalignment of language leads to delays, wasted effort, rework, defects, missed deadlines, maybe even recalls and failed audits. To create a common language that aligns teams, organizations need a controlled vocabulary. This vocabulary forms the digital thread that transcends teams, tools, and activities. Simient is a virtual assistant that extracts this vocabulary automatically from the product description that you already have and makes it accessible to all team members that works with all web-based applications.
Okay, so Michael Jastrom is making the point of the importance of a controlled vocabulary as a unifying element in an organization or a project or an enterprise. And again, it's to facilitate that effective communication. I'm cycling back to the 29148 slide. So although 15288 does not talk about terminology and formally defining it and applying it consistently, perhaps it should. So I've gone ahead and scratched out requirements and replaced it with systems, and believe that systems engineering should formally define and apply consistently the terminology in the domain in which it's working. The center two elements in this slide are, again, focusing on natural language requirement patterns of the structure of that natural language. And I've grayed out the actual natural language, and I'm just focusing on the clause types that would form a natural language requirement. And I just want you to try and keep in mind what you're seeing here as far as the elements of a natural language requirement. And when we get to a property-based requirement, you'll see some similarity. So, property-based requirements in the SysML specification. I put this slide in the presentation so that everyone understands where the PBR work actually originated from. And it was from Patrice Miquon. So Patrice has a theory of property model methodology. An element in that methodology is property-based requirements. And it was John Watson back in January of 2012 who wrote this issue against SysML 1.3. And some years later, this concept of PBRs found its way into SysML 1.5, and it exists in the current 1.6 spec. And it's in Annex E, E8, and it talks about building these property-based requirement extensions. And in the overview paragraph, what I have highlighted is, I think, the most important part of the paragraph. And it's asserting that a system model may be a model-based specification, such as when block instances. So it's not a descriptive architecture description here. It's a prescriptive architecture description. And so you use block instances with specific property values that actually end up representing the requirement. And so you'll see how that ties into a PBR. Now, so this is the text that Patrice wrote, Model-Based Systems Engineering, which has absolutely nothing to do with SysML or UML or any of the graphical modeling notations. It deals expressly with algebraic logics. And so in Patrice's mind, his PBR is a constraint on a property of an object that shall be held when a condition is met. So when you look at a formally written requirement in his method, the PBR hash n, that's the ID of the requirement. And the logic is saying, so when condition C is true, the value of the property of the object, right, shall belong to the domain that's defined by D. And so condition can be a condition of the system, the object, or it can be something in the system's environment, an object in a system's environment that actually is the context for when the requirement is actually applied, when it has to be true, when it has to be conformed to. And so if we look at UML and SysML, how can we potentially apply this concept of a PBR? So if you look in the SysML spec, you'll see there's a number of ways that are discussed. The approach that I adopted when I worked with Garima at Ford on modeling purely mechanical systems was this approach of using object constraint language to specify that the bounds of that property value. So if you look at an OCL constraint, you have in the constraint text, the context is the object that the constraint is against. INV means that this constraint is of type invariant. The domain O.P is strictly the name of the constraint, and the specification of the constraint is essentially, I'll read it in long terms, right? It's P, which is a property of the object O, is greater than or equal to domain boundary min. So everything that I've highlighted in the blue there is the definition of D, right? It's the definition of D as it regards to that property of property P of object O. And you'll see how we implement this approach in Magic Draw and when we get into that model. Before I go there, if we look at a PBR example, refactoring what's in the ISO 29148, mostly because I'm a radar guy too. I spent many decades in the radar world. As a matter of fact, when I worked down in Australia, I worked on their over-the-horizon radar network called JORN. So I might write the requirement this way without all the carriage returns. I created the line feed so that you could see the definition between the different properties that we're concerned with. So C clutter is the object. Backscatter is a property of the object. The clutter coefficient has to be C state 1 backscatter. So I'm saying this is the value specification for this property of this object. And it has to hold true from a state perspective, which is why I've used the keyword while. The next object that's part of the condition clause is the target object. And it has three properties which have to be true for the condition clause to hold. And so when the condition clause is satisfied, then the radar system, the object, its property, probability of detection, shall be no less than 90%. That's the domain specification. And you'll see when we look in the model that we can specify this be no less than 90% using object constraint language. So before I jump into the model, I would like to say the work of 29148 and 29119 inspired my work. And so I'm glad for the many individuals who contributed to those efforts. To Patrice for his work in property model methodology, to Giancarlo for his ontology work, to Scheiferdecker and Wendland for their work in the UML testing profile, who I had the privilege of working with at Lockheed, and for Michael Jastrom for his work in the requirements interchange format, the OMG spec, and for Symient. And before getting into the models, I just have to put this plug in. In my experience, excuse me, can't click there. A practical guide to SysML is frequently the only text which modelers have ever looked at prior to creating diagrams in some modeling tool. And I argue that's really insufficient. I'm not saying that you need to read all these texts cover to cover, but you certainly should read more than a practical guide to SysML. You should have perused the OMG specifications to know what's where in them so that when you have a question, there's a lot of good stuff. If you're modeling in SysML, remember that there's a whole collection of concepts that are called UML for SysML. And the only place that those are described is in the UML spec. So if you've never picked up the UML spec, but you're using those constructs in your SysML model, you might not be using them in conformance to the spec because many of the tools don't enforce all the rules of the language. Okay. So we'll exit that show. Close the PowerPoint. And okay. Okay. So I'm having a little difficulty changing my share.
We're seeing Cameo.
Oh, you are? Okay.
Yes.
Because the green frame isn't showing up for some reason. So I'm not going to go over this model 100%. This model is an implementation of the OMG's UML testing profile 2.1 specification. So I've taken the XMI from the spec and probably 90% of the text in the spec and placed it into this model. Okay, so this model is actually a profile that you could use to model test systems and systems of test if you were to choose to do so. So let me focus in because I know it's too small to see much. So you can see here that I have glossaries, and looking over in the containment tree, those that are familiar with Magic Draw know that if it's grayed out, it's really a usage of a model. So you can see that I'm using many of these model libraries or other profiles. I'm using them by reference. So ISTQB, International Standards Test Qualification Board. I think that's the right name. So they have a vocabulary, which I've placed in a glossary model, and that's all that's in that model is just a glossary of the ISTQB. And the reason I did this is the UML testing profile seeks to be usable by the methods employed by the ISTQB processes and methodologies, okay? So that's why it's here. And if you're familiar with how glossary tables work in Magic Draw and Cameo, when you place a concept, a model element in a glossary table, any description that it has, if that description is repeated or the term is repeated anywhere, it's underscored and you get this hyperlinking. And I think what's interesting about this one term here, so in the ISTQB domain, abstract test case refers you to high-level test case, which kind of says that abstract test case, or it implies that it's a synonym and the preferred term is high-level test case. And so in the little dialogue that pops up, we see that high-level test case in the ISO 29119 glossary refers you back to abstract test case. So it's kind of an interesting circular approach. But I pointed out because this is, I think, of the value of these glossary tables and creating controlled vocabularies is the ability to get this hyperlinking and to explore the conceptualization of the terms. And so this high-level test case is from the ISTQB glossary, and it gives us a definition of what a test case is. Now, I think that the approach that NoMagic implemented for terms is overly simplified, because essentially all you can do is create a term, which is created as a class, which I don't believe a term is. It uses the documentation field of that model element for the definition, and it has a tag that allows you to specify a synonym for that term. In this particular controlled vocabulary, this is a profile that I use, and there are many other properties, only a few are shown here, that are attached to the term. And in this case, the term is actually an instance of the class term. So, and it's actually a vocabulary term, which is a specialization of term. And abstract test case, I treat as an object rather than as a class, okay? Because when we go back to that semiotic triangle, the entities that are in the real world, that thing, that's an object. And my argument is, maybe wrongly, is that the symbol that represents that real world object is at that same level of abstraction, which means it's at an object level. It's not that important. It's a little bit of a pedantic rule of mine, but that's the way I think. Now, what's important in this model and what I wanted to focus on is we have a UTP conceptual model. So this is that section 7 of the UTP specification. So this is just an index to the diagrams that I'm really replicating these diagrams from the spec. And you're going to see that there are rectangles in the diagrams, and there's, I was going to say lines. I'll say lines between those rectangles. The rectangles represent a noun concept. And the line, which appears to be an association, actually represents a verb concept. So in a conceptual model, constructing this language, and this is based on the SBVR, that's what the graphical notation represents. So if we go and look at, there we go, test architecture. Make it as big as possible. So there's a lot of text here. We won't try and read it. If you're really interested, like I said, I told earlier, these models are available on my web server, and you can take them. As far as I'm concerned, if you have a need for using the UML testing profile and this model suits your needs, be my guest. It's only draft. It's not 100%. I guess it's 95% there. So this diagram is talking about the concepts that constitute a test architecture. And so the key aspects are the concept of a test configuration, the concept of what a test item is and what a test component is. And you can see here that this relationship really is saying that a test configuration specifies the configuration of a test item. And the test configuration here is shown as a noun concept that's specialized to this relationship. And it has a constraint that says it is necessary, and I don't know why they didn't use required, but this is how they phrase things. It is necessary that each test item configuration specifies the configuration of at least one test item. So it's setting down what the objects are, what the relationships between the objects are, and some of the rules of this conceptual model and this language and how to use it. And we can see here another one of the aspects of the test architecture is a test configuration is declared for a test case. That's how you read it. And a test case has a constraint which says it is necessary that each test case invokes at least one test procedure as a main invocation. So test procedure doesn't show up here because it's not an element of the test architecture, but there is a constraint on test case that says you need to do this when you specify a test case. And it also tells us here that test case is a member of test set. So this is an example of a conceptual model. It's in a profile. So that's the modeling language we can use to specify a test system and a system of tests. And we'll look at one other element so I don't run over. So let's look at test data. There we go. So in this conceptual model, the subject area, the domain, is test data. That's the domain within the construct of test that this particular conceptual model is addressing. And I won't go into all the intentional level definitions and extensional level. You can read the spec if you want to understand it. I don't know how many people have actually read the original UML testing profile, but the concepts of data pool, data partition, and data specification, it was there. So what's interesting here is, remember on the prior concept, the prior view, there was the concept of test component, which is part of the test architecture. And a role, in this case, this is what a role of the test component is to be a data provider. And this data provider provides data according to the data specification. And so the data specification could take a number of different forms, okay? But it's specifying the rules for constructing the data that this data provider provides in a test system. And the data provider is also placing data, provides data to a data partition. And so if you were to look at a data pool and a data partition, there would be partitions that specify the input values to a function, for instance. And there would be a partition that specifies what the observation of the output of that function should be. And then, and that would be selected in the data pool, based on some criteria. So you could actually have a test case that runs through a whole sequence of sets of data that are in a data pool. And it's still a single test case, but it's kind of data driven. So there's a lot here to consume, and it's not something that's going to happen tonight. But again, with the specification with this model, I think you'll get a pretty reasonable understanding of the UML testing profile. So I think we'll save the questions after the next model, because I'm not sure from a time standpoint where we're at. So this model exploits or embraces Patrice's PBR concept. And I would argue that the conceptual model of the PBR concept looks something like this, okay? This formal logic equation might look something like this if we were to look at the elements of a well-formed requirement. So how did I get to this point of talking about PBRs and OCLs with GARIMA? So this particular diagram tries to convey the problem that we were looking at solving. And I'm coloring way outside the lines of a use case diagram. Yes, I know that. But some of the people that this diagram was exposed to didn't read UML or SysML, so they didn't care. They just said, oh, this is a diagram. It's a picture, block diagrams. I get it. So the problem space says we have a repository. It wasn't DOORS, but DOORS is a requirements repository that all would recognize. And the requirements are submitted to Magic Draw. And here the requirement that I'm submitting is the clearance requirement. So I'm very focused on the requirement that I'm interested in capturing in the model in MagicDraw. And CATIA is a CAD tool that the organization has. So we essentially are stipulating the tool bench, right, that we need to employ to solve the problem. And the problem is get the assembly clearance property values. So they mock up an assembly virtually, and they specify it in a prescriptive design model in using MagicDraw tool. And so they submit the part specification of that assembly, and they're essentially those are submitted to this secondary actor, which is the 3D CAD tool. Now, many people would use blocks with actor stereotypes on them. I don't do that. I consider the actors to actually be a role of some other entity. And so I've allocated this prescriptive design model to a MagicDraw model. And that's not what it really says here, I know, but I didn't want to make it any more complicated. And I've allocated this 3D CAD tool role to CATIA. And the subject of this use case I'm asserting is this 3D CAD modeling service. That's what's going to provide these clearance property values in response to the part specification we submit. And I'm allocating that subject to an interface. And so this is a standard UML interface. And I'm asserting that CATIA must realize this interface, and MagicDraw will use that interface. And the association between MagicDraw and CATIA is really showing, I believe these actually might be information items, right? They're information flows between the two tools. And so that is the problem that the PBR is aiming to solve. So if we look at the original requirement, we're going to run out of time, so I'm just going to go right to the PBR. So this is a standard SysML requirement, and this is the requirement as it existed in the requirement repository. I've grayed out and highlighted in red text, which I believe is totally should not be here, but I can't control that. And I'm focusing only on the text in black, which is named wheel clearance requirement and has this 131566 ID. And it's basically, when we read it, it says the clearance between the wheel and wheel related components, I'm skipping the stuff in parentheses because it's not material right now, shall be a minimum of 7 millimeters throughout the extremes of wheel travel. So wheel has a set of state properties that are associated with this wheel travel. And unfortunately, this context or this condition clause gets kind of separated. And I know Lou Wheatcraft may still be here, and he might be okay with this structure. I'm not. I do know within the community that would be doing this design, none of these terms are ambiguous. But let's face it, we know they're implying that the wheel is the thing the car moves about upon, but there are many other types of wheels that are in a vehicle. And wheel-related components is, who knows what it is, because it's not defined. So I would argue it's not the quality of this requirement is not well structured. So, focusing on refactoring the natural language text into text for this PBR. And this PBR, the stereotype PBR, inherits its properties from the abstract requirement in the SysML. So it does not have the constraint of not allowing attributes or operations on the requirement. So that's why it has attributes, and then, but it has the text, and you'll see that the text is hyperlinked. And so, circling back to the conceptual model and controlled vocabulary, the conceptual model has all these concepts captured in it and defined, right? There is a concept associated with each one of these elements in the conceptual model. And so when I select that element in that natural language statement, double click on it, it takes me to the specification for vehicular wheel. And so I can see specifically, well, what is the conceptualization of the vehicle wheel? Well, it's still somewhat abstract. And we know that because it's italicized. So we know we can't instantiate a vehicular wheel. So there must be another series of refinement to vehicular wheel before we can actually instantiate it. And so what this requirement now states is, while vehicular wheel object property travel state is any state, so any state that the wheel can possibly travel through is a condition for the rest of the requirement. And this may be cumbersome the way I worded it. Apologies. It says any object property of a subclass of clearance, which is the object, and the property is clearance. So the object is clearance, the property is clearance, and I've stereotyped it with this clearance property. And essentially, this clearance property refers to this block, which is again in my conceptual model, which is a super type, which I've defined for the sole purpose of ensuring consistent spelling of clearance and also to capture clearance dimension uniformly, so that anywhere in the model where a clearance needs to be specified, it will trace back to this block specification. So because this property-based requirement has the properties of an abstract requirement and the properties of a class, because there's generalization relationship, it inherits these properties. And that's, for those of you who read SysML and UML, you know that this little caret basically says that this is an inherited property. So it inherits these two properties from this clearance block. And we add a property, which I've stereotyped property requirement, and a convention that I use, since it's a constant, it's all caps, clearance requirement. Its type is clearance dimension to make sure we don't have a type mismatch. Don't want somebody doing something in meters and somebody doing something in inches. And it's asserting that the value, so this case I am using defaults. The default value for this clearance requirement is 7, which traces right back to the natural language requirement. And I've set it that it's read only, which says that nobody can change it. It's fixed. Am I doing okay on time? Okay, I guess I am. So this particular diagram, when we look at the full screen, it's too small. But as it's labeled, it's an OCL constraint hierarchy, and it's a graph. And I'm showing this generalization hierarchy as these properties and constraints flow through the model down to the elements that they're really applied to. So we have this super type. It provides the properties to the PBR. The PBR has the actual requirement value. You might remember that the requirement talked about vehicular wheel to wheel related components. So we see vehicular wheel block and a wheel related component block. These are both abstract, so they need to be further refined. But this is an association class, and it says this association between these two model elements has properties. And the properties are the clearance requirement and the actual clearance value. And this OCL confirms that when you instantiate the subclasses of this class, this OCL should apply. So these two blocks are representing the clearances between the road wheel and a strut clevis, and the road wheel and a knuckle. And so they have their own unique identifying names, and you can see that they're not italicized, so they can be instantiated. And what that would look like, this would be a very small view, a very focused view of the assembly prescriptive model. And I'm identifying that the assembly will consist of, in part, knuckle 1, 2, 3, 4, whatever that part number actually represents, strut clevis SC200, and road wheel 98. Now, the SysML model doesn't need to know all the details about those parts because CATIA knows that. CATIA can reference its data set based solely on these IDs of the blocks which we're submitting. And because this link between these objects has been typed by that association class that we looked at in the prior diagram, the properties and constraints can appear on this diagram. And so this is one design study, and this would be another design study where we've changed the strut clevis. Now, here the clearance values have been populated, which says it's really returned from CATIA. So if we construct a table that looks at these values, now if we know because we've committed it to memory that the value of clearance must be equal to or greater than 7 millimeters, and that this 30 millimeters is kind of a number that we don't expect, it's out of bounds. And essentially, right, that's well more than an inch. And we're probably not interested in clearances in this case that involve an inch or more. So if we use the validation tool, which is in Magic Draw and Cameo, which will actually confirm, because the constraint's been applied against these association classes that typed these links. So if we run the validation tool and they don't conform to the OCL spec, those rows, an error is thrown down here in the validation calls, and it turns the non-conforming properties red. So you're going to say, Geoff, this is a lot of work, and it is. There's a lot of overhead associated with doing this. So if you believe the return on the investment of the overhead burns down risk, it might be worth doing. Maybe if more people want this kind of capability, especially organizations with large license counts, DSO might implement some more automation in this, coupled like with the work that Michael Jastrom is doing on artificial intelligence and constructing controlled vocabularies and requirements, natural language requirement statements. So at that point, I guess we'll turn over to see if there's questions or if there's anything you want to dive deep in the models. I know we're actually out of time.